Hello everyone, welcome back to the channel. In this video, we will talk about supervisor architecture in LangGraph. But before we move on to the supervisor architecture, I'll just like to reflect back on this playlist here. So I've created this playlist on LangGraph. So I'm covering all the different aspects of LangGraph, various topics, both theoretical and I'm giving code for each and every topic here in all these videos. So we started with introduction of LangGraph. Then we talked about state graph. Then we talked about React agent using LangGraph. Then we also saw model context protocol, which is a new topic. And how can we use model context protocol along with LangGraph? And we saw a sample project using MCP and LangGraph. In the last video, we started multi-agent system, and we understood various types of multi-agent systems in LangGraph. And we also started off with the first type of agent, first type of architecture, which is the network architecture. So we have already seen network architecture. And we'll be seeing the other types of architectures in the videos to come, right? And also, I've been putting all the code in this entire playlist in this repository, LangGraph repository here. So you feel free to go to the repository, take the code and tweak it according to your requirement and your needs. So in this video, we'll be starting off with learning the second type of architecture, second type of multi-agent architecture, which is the supervisor architecture. So we will see, we'll learn everything from basics from scratch. We'll understand what is supervisor architecture. We'll understand why do we need it. We'll understand how do we build it with real life examples, real life analogies, right? And then at the end of this video, we'll also see a project or a sample use case using supervisor architecture, which will make everything crystal clear. So specifically with respect to supervisor architecture, right? So this is going to be a one-stop solution for this particular topic. So you can just go through this video, go through the code, use the code. So this will be entire concept plus the code end to end, right? So now let's get started with the concept first. So let me just select a marker here. Okay. So first of all, we'll be studying about supervisor architecture, right? And we'll be building a math assistant here using supervisor architecture. Okay. So first of all, let's see what is supervised architecture. So imagine you are in a group project and one person is assigning work while others are doing the actual tasks, right? So that's exactly how supervised architecture works, right? So it's like very intuitive, right? So we work in a team where we'll have a lead who will be assigning tasks to others, right? So he will be the supervisor, and the remaining people who are working under him are going to be the worker agents. So this is the definition of supervised architecture, right? So today we are going to learn how to build a smart math assistant that can solve expressions and give formulas, right? So using just Python and LangGraph. So we'll be covering this concept with really simple Python functions. We won't be doing any complex stuff here. We'll be just taking simple Python functions to build the tools and agents, and then we'll be integrating everything together. We'll orchestrate everything together using LangGraph workflows, right? So it'll be all simple with no complexity at all. And then we'll go step by step, right? We'll see some real life comparisons. We'll see some examples. So next is, before we move on, let's understand what are AI agents, in really simple words. So an agent, so basically think of an agent like a person who's good at doing one job. So just think about a person who's expert in doing one job. Let's say in a team there is a Python developer, right? So he is expert in writing Python codes. So that is one agent, right? Similarly, uh, an agent can be any function or any tool which is good at doing one job. So agent necessarily is not only function or tool. Agent can have various various functionalities. It can have a LLM, it can have tools as functions, right? But it will be expert at doing a job, doing one job particularly. So now let's see, for example, a calculator agent who solves math expressions. So this particular agent is expert in solving math expressions. A formula agent who remembers formulas, like the formula for this particular area is equal to pi r square. So this particular agent is expert at remembering the formulas, right? And this agent will be having again an LLM and one tool or multiple tools to do these activities like solving the maths or remembering or recalling the formula, right? So so this agent can use LLM and various tools, multiple tools, to give the required response. Then we can have a supervisor agent who tells which agent should work on which task. So in context to supervisor architecture, so we can have two types of agents. So these two are basically the worker agents, right? These two are worker agents, and this one is the supervisor agent, right? So this is going to tell the worker agents what to do. Given the user query, this agent is going to decide which agent is going to be used to solve that particular user query, right? And then they, all of these agents, talk to each other to answer the query, right? So this is typically a multi-agent AI system. So this is just like a real team working together. So now we'll see what tools we'll be using in this particular tutorial. So we'll be using, first of all, of course, we'll be using LangGraph to build the orchestration or the workflow. We'll be using Olama, right? So you don't need any API keys, any access to any online models. We'll be using local models using Olama, and we will be using Llama 3.2, Llama 3.2 here, right? And this will be available locally on our laptop, and then of course we'll be writing the entire code in Python. So as I said, we won't use anything complex. It will be just clean, simple code and logic, right? So it will be really easy to understand. Now let's understand a real life analogy here at this point. And then we'll connect this analogy to our use case, which we'll be doing later. So let's think about a pizza delivery team, right? So let's say you ordered a pizza. Okay. So you are the user, you ordered the pizza. Now the order manager or the supervisor decides what needs to be done. So there will be a manager at the pizza store, right? So your order will go to the supervisor. Then he will decide whom to assign the next task. So what will the next task? So next task will be to cook the pizza, right? So now so the supervisor is going to ask the cook agent here to start cooking, because this particular agent is expert at cooking pizza or making pizza, right? Because he knows the recipe. So this will be similar to the formula agent which we will see in our use case. Then the second agent is a delivery guy, right? So the delivery agent, basically he finds out the route to your house, how to reach to your house to deliver the pizza. So this particular guy, this particular agent is expert in finding the route and delivering the pizza, right? So this will be similar, this, let's say this is similar to the calculator agent which we will see in our use case, right? That's exactly how this particular architecture works, so now we just swap the pizza with math problems, what we discussed before. So it will be a very similar flow where we'll be having a supervisor. We'll be having a supervisor agent which will decide which agent to invoke based on the user query. Based on the user query. So for example, let's say the query is what is the area of circle with radius 7, right? Let's say the question is what is the area of circle with radius 7. So this particular question, based on this question, the supervisor is going to decide which agent it can invoke, right? So particularly in this particular question, it might need to invoke both the agents. It might need to invoke the formula agent first, so it will find the formula to calculate the area of a circle with given radius, and then after it knows the formula, it might need to invoke this calculator agent to find the actual, actual area here, right? Then, okay, there seems to be some problem. One second, let me just refresh this page. Okay, so we are back here. So we were at this point. Sorry for the interruption. So we were exactly at this point, right? So we discussed that based on the user query. So here, based on the user query, the supervisor agent is going to decide which particular agent to invoke. So here it can invoke both the agents, depending on the query. So here we see that first of all, the flow will be like this. The supervisor here asks the formula agent, what's the formula for area of circle. So it finds out the formula, then it asks the calculator agent to solve this particular equation. So finally it is able to return the answer, right? So that is how the handoff takes place, right, between different agents. The user asks the question, that goes to supervisor, then supervisor decides which agent to invoke. If needed it can invoke multiple agents to get uh, the final response, right? So now let's see how the code is working here. Let's see step-by-step implementation of the code. So the first step is going to be, we'll be defining the tools, right? We'll be defining the tools, the agent skills, right? So we give each agent a tool, like a function. This tool is nothing but a function. This is a Python function, right? You'll see in the code, but this is nothing but a Python function. The first tool is the calculator tool, right? So it takes math expressions and gives the answer. Second tool is the formula tool, right? It takes the topic or the user query and then returns the formula for that particular query. So both of these are simple Python functions, right? So tool is nothing but a Python function. It can be a tool, can be the pre-built tool, like a Tavily or DuckDuckGo, right, or any weather API, right? Or it can be also a custom built tool like a Python function, which we are, using here. Then next we are going to define the agents, right? So step two is we are going to define the agent. So each agent is created using the model and the tool it needs, right? So as I said, every agent will have LLM, which is the model, and it will also have the tools. For example, the calculator tool, let's say calculator tool or calculator agent rather, this will be having, let's say the LLM. Here we are using Llama 3.2. It will also be having the tool, which is the calculator tool, which we made earlier, right? Calculator tool. Using these two things, it will try to basically give the final response. So that's what we are discussing here. So the calculator agent uses the calculator tool. The formula agent uses the formula tool. They will just wait for the supervisor to call them, right? So they are ready. Both of these agents are ready with the model and the required tools. Now they just wait for the supervisor to invoke them based on the user query. The third one is that we'll create the supervisor. So the supervisor is the brain, actual brain, the actual head here. It decides who to call next. It decides, should I call the calculator or the formula guy or end the conversation, right? This decision is made by the model based on what the user asked. So the user asks something here. The user asks a question. This goes to supervisor, right? Now supervisor is the in charge here. It decides whether to call calculator agent, calculator agent, or to call the formula agent, or to call both, right? It can call both also based on the user query. Then finally, uh, let's say it sends the flow to the calculator agent. Calculator agent finds the answer, it goes back to supervisor, and then supervisor can go to can just return the this response, and the flow will end here, right? Or if the supervisor feels like it needs to get some more information from the other agent also, it can then call the other agent again, this formula agent, and based on that, the formula agent is again going to communicate back to supervisor agent, and then it can return the final answer, it can end the flow, right? So this is a typical supervisor architecture flow, correct? Now let's see what we have next. So next we are going to define the state. Probably this is not the next step, but the state basically flows through the entire flow. So this is like this is like the notebook where we track what messages were exchanged, who should go next, and how many steps are left, right? So this is like it kind of uh, maintains the variables throughout the flow. So we'll be able to use the variables in the state dictionary throughout the flow in different nodes in different agents, right? So this is the work of the state. So we'll be defining the state also. Now in this video, in the coding part, we'll also see a very specific or particular problem which I encountered while doing this coding. So there is a problem called as recursion limit error. So when you will run the flow, this LangGraph flow, it will by default it will run 25 times and then it will give the error. You know, sometimes the agents keep calling each other again and again like an endless loop. So this the issue is that endless loop, right? So the endless loop is the problem. So the error will be graph recursion error, recursion limit of 25 reached without hitting the stop condition, right? So by default, the recursion limit is 25. So it will run 25 times. And then if it doesn't encounter or if it doesn't hit any stopping condition, it stops, the flow stops giving an error, graph recursion error. So how do we fix it? We add a step counter. We add a step counter. We add remaining steps in the state. So what is the meaning of remaining steps? It's like we are saying to the flow that you have only 5 steps. Solve the task or shut down or close it. Close the flow. You know. So either in 5 steps you have to solve the problem, or you say you basically end the flow execution. How does this help? This helps to stop the infinite loop problem, right? And this recursion error problem. And then this basically helps to get rid of this particular error, right? This is a very typical or very particular error, which I encountered. So this was it on the conceptual side of it. So we have seen, just to recap, we have seen what is supervisor architecture, using various real world example and analogies. We saw what are AI agents. We saw what tools we'll be using. We saw a real life analogy. Then we also saw a sample flow here, which we'll be creating next in the coding section, right? Then we also saw a very specific problem of graph recursion error. Now let's move on to the coding part here. So guys, this is the code here. So I've already put this code in the GitHub repository here. You can find it here. So this particular code is Math Supervisor Architecture. So you can take this code from here and play around with this code. So now I've already written the code just to save some time here. I'll be giving a quick walkthrough of this code. So we start off with importing all the required modules here, first of all, right? So we import from typing, we import annotated literal, then we import typed, then we import message state and state graph start from LangGraph graph. Then we also import the command from LangGraph.types and then so on. Then we also import the create react agent module from the LangGraph.prebuilt. And then we are using the chat Olama from LangChain Olama, right? To use the LLM. Then this particular remaining step we are using to encounter the graph recursion limit issue, right? We'll see how to use it. So then we'll first of all, call the model here Llama 3.2, and we'll just test, if this model is working. So this model seems to be working, right? Then we'll be defining the members of this flow, calculator agent, formula agent. Then we will also defining a finish, the end point basically. Then we create a router. So this router is what? This basically this will help to route to various agents available, right? Like calculator agent, formula agent, or finish. If basically if no workers are needed at a particular point, it will just route to finish node or end node. Then we create a state here, message using message state. We create this next variable and remaining steps variable, right? So these things we have already seen in the previous videos. You can refer back to the videos to get some more context. But here we are creating the state class so that we can use these particular variables throughout the workflow. So that is the work of a state, right? So it is like a dictionary. So we can use the keys or values inside the dictionary throughout the workflow, right? So that kind of helps maintain the variables through the entire workflow. Then we first of all create a supervisor node, but we define the system prompt first. We say, so you're a supervisor, tasked with managing a conversation between the following workers. The workers are nothing but the members we defined here. This is the worker nodes or worker agents, right? So given the user's request, respond with the worker to act next. So here we are saying the supervisor node or the LLM here inside the supervisor node to basically return back the worker node which needs to act on this particular user query, right? So here the LLM will decide exactly which worker node needs to be called to act upon the user's query. So each worker will perform a task and respond with results and status. When finished, respond with finish. When finished, respond with finish. So we are defining clear-cut instructions to the LLM here present inside the supervisor node, right? Then we are again using the command here to create the flow. We are saying supervisor node will go to calculator agent, formula agent, and then end, right? So instead of adding edges, we can also do it this way to perform the handoff between different nodes or different agents, right? So then we are this at this point we are defining or we are using that particular remaining steps variable inside the state here to say that if the remaining steps is less than or equal to 2, we are going to call the end or we are going to end the flow. So using this, we are handling the graph recursion limit issue. So it will not go inside the infinite loop. If it finds the remaining steps is less than or equal to 2, it will go to end. Then we are creating the basically message variable here from the state here. So we are saying role is system and content is system prompt. This is a system prompt, and then state is messages, right? And then we are calling this Olama model and we are invoking it using this particular prompt. And then we say go to response next. If go to is finished, go to end, or we use this command again to go to the next agent or next node, right? So that this is the supervisor node. Then we start off with creating the tools for our worker node. So the first tool we have is basic calculator tool, right? So what will be the input here? The input will be a basic arithmetic expression like this one. So what will this tool do? So we must define the doc string here, right? We must mention what this tool is going to do exactly. So this will be evaluating a simple math expression and return the result, right? And we are using this eval function here to do the calculations, right? So we'll be using this particular tool inside the calculator agent node or this particular calculator agent. So again, this will be returning the response back to supervisor here, right? And then we are calling the create react agent from LangGraph pre-built. We are putting the model over here. So every agent we discussed, right? Every agent will have the model and will have the tools here. So we are using the Olama model, Llama 3.2 here, and the tool is the basic calculator tool which we defined over here, right? Then we are returning the update here, right? Based on the output. And then we are again going back to supervisor, go to supervisor, right? So that was the flow here, right? If we see the flow here, where's the diagram? 1 second, right? So supervisor can basically invoke or pass on the flow to the calculator agent, formula agent, or it can just end the flow. So based on the query, calculator agent will find the response or get the response, and it will again give back the flow to the supervisor, right? So that's what we are doing. So this calculator agent is going to go back again to the supervisor agent here, right? After it finds the response. Then we have the next tool, which is the math formula tool. So here we are creating like a sample or dummy tool where we are already defining some formulas here, right? So what will the input here? A math topic like area of circle or quadratic formula, and this will return standard math formulas based on the topic, right? So this is a simple dummy kind of tool where we have already defined some of the formulas, right? So based using this particular dictionary, it is going to return back the formulas based on the user query. Then we using this particular tool, we are creating the agent here. The agent is formula agent node, and this will be again going back to supervisor after getting the response. Right? Go to supervisor, right? And then we are invoking this formula agent over here, right? Using the create, we are again using the create react agent. We are passing the model, we are passing the tools. This is simple, right? So similarly here, what we did, we are doing almost similar thing here also. Now we are going to create the graph. So we are creating the graph using the state graph here, state graph class. And inside this, we are passing the state. So the state has all the variables, whatever we have been creating as of now. It has all the information, all the messages, all the prompts, right? Now we'll be adding the nodes. The first node is supervisor node. We're calling this a supervisor, right? The second one is the calculator agent node, because we are calling this calculator agent. The third one is formula agent node. We are calling this formula agent. And then we add the edge here. We just need to add one edge because remaining we have already added using this command here, right? We're just adding the edge between start and supervisor. So if we just visualize this particular flow here, you can see that the flow starts from here. Start, then the user asks the query goes to supervisor. Supervisor, based on the query, decides which particular agent it's going to invoke, right? Or based on the query, it can also invoke both the agents one by one. So let's say the query is related to calculating some expression, so it will send it to this particular agent. Or if the query is about finding, let's say, finding the area of a circle, like we saw in the example. So first of all, it might need to find the formula for finding the area of circle given the radius. So it will go to the formula agent, and then the formula agent is going to respond back here. So here now the supervisor has the formula. So now it will be again asking the calculator agent that using this formula find the area of circle using the given the radius and the given formula. And then then again calculator agent will find the response. It'll respond back to supervisor, and this particular supervisor agent is going to return back the final response to the user, right? So this is the handoff architecture basically, where there are multiple handoffs happening between various agents. Now let's see an example here. The first question is what is find this, but the response for this particular expression 12 into 5 plus 3, right? So here we are also saying remaining steps 10. So we're just saying that you have total number of steps 10. So find the answer in 10 steps or just end the flow here. Do not go into an infinite loop here, right? So if we see the response here, we can see the handoff happening over. This is really interesting. So it starts off with the calculator agent, right? And then it finds the response. Then it again hands off to the formula agent to just check with the formula agent if this is the correct formula, right? Then again it calls the calculator agent. Then it keeps on calling the calculator agent to find the final response, right? So if you see, this is the final response over here. So this is the last step where it called the calculator agent. It found the answer. The result of the expression is this one, right? So, and if you see, it is using the calculator agent here. The agent name is calculator agent, right? Now let's see the next formula, or the next query. The next query is give me the quadratic formula. So it starts off with calculator agent, right? And then after calling calculator agent multiple times, it goes to the formula agent to check if there is existing formula in this particular tool, right? So at the final response, you'll see it is using the calculator agent to give the final answer, because the calculator agent is also having an LLM with some previous knowledge, right? So it might also return back the answer for a particular for a particular question, right? So yeah, so based on the context and the user query, it's never fixed that a particular agent is supposed to give the answer, because the LLMs have their own knowledge. So the LLMs can also take the query and return a response. But the important thing to note here is the handoff happening over here, right? So multiple times the handoff is happening between these two particular agents, like calculator agent and the formula agent, right? Now let's see the next question over here. The next question is basically where we have both the we might need both the agents, the formula agent and the calculator agent. So we're asking what is the area of a circle with radius 7, right? So first of all, it goes to the formula agent. From formula agent, it finds out the formula, that the formula to find the area of circle given the radius is pi r square. And then it calls the calculator agent, using which it finds the response here, right? So then it finally it checks multiple times to confirm that the answer is correct. So multiple handoffs happen, and finally it returns the answer using the calculator agent, right? So if you see here, it gives the final answer, and then the agent which is being used here is the calculator agent, right? So this is the concept of supervisor architecture. So where basically, given the user query, the supervisor decides which particular agent it needs to call, and then it finally gives the final response based on the responses from the individual worker agents. So this was all for this video. uh, if you like the content, like the video, subscribe the channel, and share the video with your friends so that maximum people can benefit from this video. And guys, please subscribe the channel, because that really motivates me to create more and more such videos, more and more such free content, for the audience. So please subscribe the channel, right? So I'll see you again in the next video. Until then, thank you for watching the video. Thank you and bye.